Hello there, ladies and gentlemen. Today we're going to talk about the one-to-one property. So basically what I want you guys to do is look at these top three equations and see if you can tell me what x would equal for each of these. Okay, so pause the video, take a second, see if you can figure out what x would equal for each of these, and then we'll talk about the reason why that would be true. Okay, so if you're coming back to us, for this one, hopefully you got that x would be 5. For this one, you would get that x would be 2. And for the last one, you would get that x would equal 3. And the reason why I got these answers is because of something called the one-to-one property. Basically, if I have the same base to my exponential function, I know that the exponents have to be equal to each other. It's kind of like common sense, right? If 2 to some number equals 2 to the 5th, doesn't that number have to be 5? Okay? And that's kind of what we see here. 2 to the x equals 2 to the 5th. Well, x has to be 5 for that to be true, okay? And we can apply that to kind of solve equations that may actually show up in our exponents. So, for example, down here, I have 3 to the x plus 8 equals 3 to the 11th. That means these exponents have to be the same, so x plus 8 has to equal 11. And then I can solve that by subtracting 8 from both sides, and I'll get that x equals 3. Over here, I have the same thing. E to the 5x minus 4 equals e. Remember, if I don't see an exponent, it means secretly there's a 1 there. So I can say, all right, 5x minus 4 has to equal 1, based off this one-to-one property. And then go ahead and solve. I add 4 to both sides, divide by 5, and I'll get that x equals 1. I would like you guys to go ahead and try these next three. Okay, so section them off here. You got this one, and this one. Go ahead and try these three, and then come back and check with me and see how you did. All right, so for this one right here, I got x equals 3 halves. 2 to the 4th gives you 16, so that means that 4 would be the exponent that goes with that. Go through and solve and get x equals 3 halves. Over here, the exponent that goes with 3 would be negative 2. 3 to the negative 2 equals 1/9. So x plus 4 is equal to negative 2, and I get x equals negative 6. Over here, I don't have to do any trickery that way. However, x squared equals 4x minus 3. That's a quadratic. I need to solve that how I know how to solve those. So I made it so it's set equal to 0. 0 equals x squared minus 4x. Oh, this should be a plus 3 if I do that. So hold on, Mr. Guy made a mistake. Let's see if that changes anything. So I did the quadratic formula. Okay, but this answer is not going to be the same based off that. What you should actually do is you can factor this now because negative 3 and negative 1 will add to negative 4. So basically I subtracted 4x and added 3 to move it over. And now we'll factor and you should get x minus 3 times x minus 1 equals 0. So x is going to equal 3 or x is going to equal 1. Okay? So that's the one-to-one property. If you have the same base and they're set equal to each other, their exponents also need to be equal. Thank you all for watching.